Okay, are you ready? Are you listening? Today we're going to talk about simplifying square roots. It might also be called simplifying radicals, or you might be asked to write your answer in simplest radical form. And first, I'm going to give you a list of perfect squares. So in fourth period, we were able to make this perfect square chart together at the end of class, but third period, we haven't made this yet. So fourth period, you could go ahead and skip past this while you're watching the video. Third period, you probably know 0 through 10 squared already. So you don't have to write all these down. I just want you to start writing them wherever you don't know the fact. So if you know 0 through 10 already, you don't have to write those down. Just start here with 11. If you don't know all these, then write them all down. This is really, really important. It's our perfect square chart. Two things I want to pick up or notice. 13 squared is 169, and 14 squared is 196. So all that we happened was we flipped the 9 and the 6. And how do you keep it straight? Look at here, we've got 3, 6, 9. So for 13 squared, it's 3, 6, 9. So you can maybe remember that. And then 14 squared is 196. Last thing I want us to look at is how to do 20 squared. What happens is you square the 2 and you get 4 and you put 2 zeros. So how do we square 30 squared? We square the 3 and then you put 2 zeros. So then what would 40 squared be? You'd square the 4 and you'd put 2 zeros. So go ahead and pause and make sure you have this perfect square chart written down. You might just want to write it down a whole column like on the edge of your paper. Just go from top to bottom and just get your perfect square chart. And then if we were going to simplify radicals, maybe the example says, write the answer in simplest radical form. Alrighty, so if the first example is the square root of 100, you say, ooh, it's on my perfect square chart. That's just 10. If the next one is the square root of 196, oh, that's on my chart. It's just 14. And if the square root is 400, ooh, that's on my chart. It's 20. So these are perfect squares. And when you take a square root of a perfect square, you get the number times itself that equaled the number under the radical. So we hear this word square root. And in math, we've heard of square things before, maybe specifically x squared. What happens if we take a square root of x squared? Well, square roots, we don't write this little 2 up here. Oh, they got lost in my queue. But it is understood that there's a little index up here of a 2. So the square root of x squared, those 2's undo each other, and it's just x. There are such things as cube roots and fourth roots and things like that. So if it's any root other than a square root, they have to put the number there for us. So if we just see this root like this, it's understood that there's a 2 there. Okay, and why is the square root of 100 10? Because you can think of 100 as being 10 squared. And those 2's undo each other, and you would just get your 10. All right, so that's taking square roots of perfect squares, where you just get nice numbers. Your answer doesn't have a radical with it at all. But what if you have problems like this? Again, it's just simplest radical form. What if it's the square root of 8? Oh, that's not on my perfect square chart. So we're going to try to take the square root of 8, and it's not on our perfect square chart. So we're going to break it down with factor trees. And you did these in Algebra 1. And you're going to keep breaking it down until you have a list of primes. Prime numbers are numbers that their only factors are 1 in themselves. So there's the first few primes. So then remember how that was a square root with a 2? We're looking for groups of 2 of the same number. So when you have a set of the same number, That number gets to come outside of the radical, and anything that's left over is multiplied and put back together under the radical. So what I say is, if you have a friend, you can go outside to play, and if you don't have a friend, you have to stay inside. All right, B. Let's do the square root of 18. 18's not on our perfect square chart, so we have to break it down. Okay, so we've broken 18 down to primes, and then, oh look, there's a pair of 3s. So that 3 has a friend. They get to come outside of the radical, but this 2 has to stay underneath. All right, so just do a few more. I'm not going to talk over these because I'm in study hall and I feel silly. Well, I'm going to go ahead and talk. I'm going to break 80 down because it's not on my perfect square chart. Every time I get down to a prime number, I circle them. And then it's only the circled numbers that I look at. And then I say, ooh, there's a pair of 2s. There's another pair of 2s. Multiplication is the name of the game here. So that 2 comes out and this 2 comes out. So we've got, with a 5 left over. I wouldn't normally write the 2 and the 2. I'd write just 4 square root of 5. All right, let's do another. Let's break 150 down. See, it doesn't matter what numbers we use to break it down. We can use any numbers we think of, and then we just want to circle them when we get down to primes. And then here we've got a pair of 5s to come outside the radical, and then we have a 2 and a 3 left over to get multiplied back together under the radical. So your assignment tonight is going to be, I'm hoping, 2 different IXLs that I can find. Wait just a second, I'll check. Alright, so I wasn't able to find IXLs in geometry, and you probably did the algebra ones last year. So here are your 10 homework questions. You're going to leave the answers in simplest radical form. We'll check these Thursday.